Go for it. Wow. Could somebody get the lights so we can get a little bit more?
Gavin's gone. Wait, where are they?
I go right out of this room, and
You
it's
go to the
like
girls'
on
bathroom.
the left hand side, right in that hallway right
It
here.
basically is one already.
Oh, there we go. All right.
Gavin, did you go to the girls' bathroom?
Yeah, I did.
All right, guys. I am ready for your first question. Go ahead. 24? Okay. So it is silent because this is a review. 24. Everybody turn to 24. Let's take a look. Oh my goodness. We just did this. What is the solution of the system of equations?
Wait, I want to answer.
Okay, so just looking, I want you to help me through this comment, okay? What method should we use just by glancing at these equations? Substitution, very good. So I'm going to take both equations. I'm actually not even going to rewrite them. I'm just going to go ahead and substitute because this expression, 2/3 x plus 5, is equal to y. And if these equations are part of a system that works together, that means this y is the same value as this y. And if this y equals this, then this y equals this. So is that what you did? Did you plug it in?
Yeah.
So I'm going to write down the second equation, 7x minus 3y. But instead of writing y, I'm going to open up some parentheses and put in my 2/3 x plus 5, and then I'm going to finish writing that second equation, equals 15. Are we good? All right, so we're just going to go step by step and solve. Did you distribute?
Yes.
I did.
Okay, so we still have our 7x here, and then we have a -3 times 2/3x. The 3's would cancel out, and then you get -2x. Did you get that, Colin?
Yeah.
Okay. And then -3 times 5 is -15. You get that?
No, I got positive 15.
Oh, silly Willy.
I got
See, that's the thing. Now listen, since Colin, you set it up perfectly, you did your steps perfectly, and I'm assuming that after you got positive 15, you probably solved the rest of it perfectly. It was just a matter of that silly mistake. That's why plugging back in your answers is going to be gold on this midterm, okay? You guys have 2 full days to do it, so take the time to plug back in your x and y values at the end to make sure it actually works for both equations. Yeah.
I thought.
Does anybody want me to keep going, or
No.
No.
no? You guys totally.
Finish.
You have a question on this one?
No.
Oh, okay. I meant, do you want me to keep going on this particular problem, or does everybody understand substitution? Do you have a question, Ethan?
Yeah, so I thought when you're multiplying the fraction by a whole number, you multiply the numerator and the denominator.
So here, let's write that out, okay? It seems that a lot of you guys in 8th grade still are having trouble understanding that there are multiple ways to solve multiplication of fractions and or fractions and whole numbers. So let's take our -3 over 1 and multiply it times 2/3, okay? There are 2 ways to do this. I'm gonna write it twice, -3 over 1 times 2/3. So you said, aren't you supposed to multiply the numerators? Yes, -6 over 3 reduces down or divides to -2. What you guys learned along the way, I don't know what grade it was. It could have been, I think 4th grade, because my 4th grader, I believe, is already learning this. 4th grade, 5th grade, 6th grade, you guys were taught that you can actually reduce the fractions before multiplying with a numerator-denominator match, okay? So if you have a numerator and a denominator in multiplication that can be divided or reduced, then you can do that. Then we have a negative times a 2 is a -2 over 1, which is just a -2. This is the quicker method. This will also get you the right answer. So the good news is there are 2 ways to do it that will get you the right answer. So do either one. Do whichever one you like, right? Just get the right answer. Stop doing that, please. Okay. Next question. I'm gonna write down which questions we did so I can. 21. Actually, can I just really quickly go through the rest of this one because I really want to, just in case there's anybody who does need this, 7x minus 2x minus 15 equals 15. Thank you. I'm just gonna go through this quickly, okay? Circle your terms with their signs to combine like terms, and we get 5x minus 15 equals 15 plus 15 plus 15. Cancel. 5x equals 30. Divide on both sides by 5. X equals 6. Now we're halfway there. We have to plug our x value back into one of the equations. Let's see, which one's going to be easier to plug in? I would choose the first one because it's already solved for y. So I'm gonna, even though it's a fraction, I'm gonna go ahead and do it because it will reduce really easily. So I'll do the first equation. Y equals 2/3 times x, which is 6. And I'm gonna put my 6 over 1 since it is being multiplied by a fraction. And then it says plus 5 is the rest of that one. Then we have 6 and 3 cancel. 2 times 2 is 4. Y equals 4 plus 5, y equals 9. So you have 6, 9. Your answer is 6, 9. On your test, you're going to plug both of those back into which equation? The second one, because we used the first one to solve for y, so we use the other one to check our answer because they have to work for both. So we would plug that back in. 7 times x. 7 times 6 is 42. And then minus 3 times y, 3 times 9 is 27. Does that equal 15? I don't know. 42 minus 27 equals negative 42 minus 27 equals 15. Yay, it works, so that's our answer. Okay, next question.
21.
21? All right. Damien works after school. Each day he earns a set amount plus an hourly wage. So what is the set amount?
F of x is equal to 12.
No.
$10.
No, he earns a set amount, meaning like each day he automatically earns a certain amount that never changes. And that would be our y-intercept. Yeah, our y-intercept is $10 plus an hourly wage. That's the part that depends on how long he works, right? And that's why there's going to be a variable there. So he gets $12 each hour that he works. The hours are represented by x because this function, meaning the function of x, which is the total amount he earns for the day, is $12 times however many hours he works plus his automatic $10. He automatically gets $10 for working. How much does he earn on Friday? Who cares what day of the week it is? It's just how much does he earn on a day if he works for 2.75 hours. So where does the 2.75 go? Yeah. So we have f of x equals 12 times 2.75 plus 10. Did you do that? Jason? Did you do that?
Yeah.
And what'd you get?
44. Oh, wait, no, wait. Multiplication?
Yeah, well, so this is 33, I'm just doing it on my calculator, plus 10 is 43. What did you get? I'm just curious, because this one's pretty straightforward.
When you distribute 33 plus 10, I think that was actually
Didn't you have a question on this? Oh, who asked this question?
Well, I just asked to like make sure I did the answer because it was the one question that I like did not check after I was finished with it on the thing. So I just wanted to make sure I got it there.
Okay, you got it right. All right, that was 21. I'm just making a list so I can, when I post it on YouTube, everybody knows exactly which questions we go over in this
Can you
session.
give me a shout out? You did the intro.
You did the intro, and you did it amazingly. I
NPC
think
wave.
you gave yourself a shout out on that one. Next question.
Alright.
And by the way, guys, we have 2 days of this. Tomorrow we're gonna go through, there are 30 problems on this, so we're gonna use tomorrow as well. Go ahead.
29.
29. Okay. 29, Kona, which is funny. Kona wants to bake at most 30 loaves of banana bread and nut bread for a bake sale. Now, just out of curiosity, were you able to get 2 equations and then something just wasn't right about them?
I just found one.
And was it this one?
Yeah.
Okay, so that one was pretty straightforward, right? She has to get a total of 30 or less, right? She wants at the most to be 30 loaves. So the inequality we would use is it has to be the total amount of loaves she makes for the banana bread and the nut bread has to be less than 30 or equal to 30. The next one, the next part says each loaf of banana bread, which we're representing with X, sells for $2.50. So each loaf, which is the variable, because we don't have the certain number of loaves, we just know that however many loaves she does make, each one costs $2.50. So that 250 times the number of loaves would, just that combination, that multiplication there would represent the money that she would make for selling the banana bread. And then each loaf of nut bread, which is the Y, sells for $2.75. So however many loaves of the nut bread she makes, each loaf costs $2.75. So the total money that she makes for selling those will depend on how many loaves she makes, and each one is $2.75. The total of the money that she brings in for each of those loaves of bread, it says she wants it to be, she wants to make at least $44. So she's happy with making $44, but she'd be even happier if she made more than that, right? So she's setting her goal at $44 or more. And anybody who's in sales doesn't just want to make a certain amount. They want to exceed it, right? So they don't want, when they're like projecting their sales, they're like, I want to make $44 and that's it. It better be right on the money at 44. No, when you're in sales, you might have a goal in mind, but you also want the opportunity to exceed it, right? So that's why we would use inequalities in sales. We want to make at least 44, so equal to 44, or we want to make more than 44. So we don't have to solve anything there, we just have our inequalities set up for us, where we set up the inequalities based on the information. Next question.
20.
Does that totally make sense, Ethan, to get that?
Yeah. Number 20.
Number 20. Okay, what are the domain and range of h of x equals 3 times the absolute value of x? Absolute value functions to me seem like we did them a really, really, really long time ago. I don't know why, it just seems really far away. Does anybody else feel like that? So without, actually, I will write this all out. I was gonna just show you my notes, but I'm gonna go ahead and write it out. Okay, so I'm gonna take, it's very hard to determine your domain and range unless you can see it on a graph. That's the best way to visualize your domain and range. The great news for making a graph is you can make up your input values. Remember, input, what goes into the function machine. And then you just solve for the output. Then you have your coordinate pairs for the graph. So if I have h of x equals 3 times the absolute value of x, I can literally make a table that solves for that. So I'm gonna make up some input values. And we know that when we make up input values, we want to include negatives and a 0, especially with absolute value. Because absolute value is the one where you put in, your input, you can put in a negative, and then boom, it turns positive, right? Because it's being absolute valued. So we have our input, then the table is going to involve the actual function, which is 3 times the absolute value of the input, and then you're going to get an output, the h of x, which is also known as y. Very good. Okay, so now I'm gonna just plug in some numbers. I'm gonna do a bunch, okay? So I'm gonna do -2, -1, 0, 1, and 2. If you want, you can do -5, -4, -3. If you really want to get a good view of that absolute value function, you could. But I highly recommend doing 5 inputs, and they're super easy. You just do 3 times the absolute value of -2, 3 times the absolute value of -1, 3 times the absolute value of 0, 3 times the absolute value of 1, 3 times the absolute value of 2. Really simple, right? You guys cannot be afraid of working these problems out. It will get you the right answer. Now, let's get our outputs. So, absolute value of -2 is? 2 times 3 is?
6.
See how easy that is? Absolute value of -1 is?
1.
5 times 3 is?
3.
I'm just gonna point because my voice.
0.
0 times 3 is?
0. So we're getting
3.
1 times 3 is 3,
6.
and 6. Very good. See how we have like 6, 3, 0, 3, 6. We see it coming back. That's what makes the V on the graph. So when we graph that, and we have, I'm just gonna look at my thing. I need to go, my Y needs to go as high as 6, so let's be 1, 2, 3, 4, 5, 6. And my X value is 1, 2. I only need to go as far as +2 and -2. So I have my first pair is -2, 6. You can even write that over here, -2, 6, -1, 3. You can write them all out and then graph them, or you can just pull them from the table. So we have -2, 6, -1, 3, 0, 0, 1, 3, 2, 6. We see what's happening, right?
V.
Yep, it's making that absolute value V. Now we analyze. It's asking for the domain. The domain is, what are the X values that will show up as on the points of this graph? Yeah,
All of them.
all of them. Even though this looks like a very skinny graph where it's going so high, it's still going outward, right? And if the arrows go on forever, as they go up forever, they're also going outward forever. And they meet at 0. So 0 is included, everything over here is included, and as the arrow continues, everything over here is included, and all the way. Everything this way, as the arrow continues, it's hitting all of the negative X values. So it's every single X value, negative, positive, everything. We call that, the domain is all real numbers. For the range, how do we describe that? Is it all real numbers?
No.
Why not?
Because it's not.
Explain, Peter. Why is it not all real numbers, Peter?
Because it's only going up, not down.
Yeah, be more specific, like look at the graph and tell me where the stopping point is, or you could call it a starting point. Yeah, it starts at 0. The Y values that are possible for this graph start at 0. Do they include 0? Yes. So it includes 0 and goes all the way up the Y-axis. What's not included is every negative number. So our answer choice here, where the range is Y, the Y values for this graph have to be greater than 0 or equal to 0. Who asked this question? Do you totally get it? Okay. So it looks like this is gonna take a lot of time, but it really doesn't. You can make that table and graph easily, and then once you see that, it's so much easier to get your answer. Okay, so that was 20. Next question, yes. I would prefer if you stayed here for the review, and then at the end of class you can. Next question. For the people who did not complete this, I highly suggest that you complete it tonight so that you have your opportunity to ask questions tomorrow, okay? Based on what you completed and did not get correct. Yeah.
4.
All right, more absolute value fun. All right, so it's an equation that we're gonna solve pretty similarly to just solving for x with a couple of twists and turns. I'm gonna rewrite my equation right here. 2 times the absolute value of x plus 7 minus 6 equals 0. Now, did anybody make the, whoops? That's not good. Did anybody make the mistake of trying to distribute here?
I did. And then I went to
I almost did,
And then you looked at my notes and fixed it? Okay.
I almost did, and then I realized I wrote parentheses instead of that.
Oh, okay. So absolute value does look similar to when a number is outside of parentheses with an expression, right? It looks similar, it is not the same thing. Parentheses, all they mean is that there's an expression inside of them that's being multiplied by something on the outside. Absolute value is so different. Absolute value means there's an actual operation happening after x is added to 7, then it's absolute valued, then it's multiplied by 2. So you can't distribute the 2 because it hasn't been absolute valued yet. So you cannot distribute. Write this down if you had a problem with that, just even if you fix it on your own, just write it down. Do not distribute absolute value, okay? What we can do though is start undoing things and solving for x. So we have this -6 over here hanging out. We can add 6 to both sides to cancel that out and start simplifying this. Much simpler, right? Now you're like, well, now can we distribute? No, because we still are up against this absolute value operation. But since we can't distribute, we can undo the multiplication of 2. What do? Divide by 2. We can't minus, we have to do the opposite of the multiplication. So divide by 2, divide by 2. Gone, gone, and then that equals 3. So don't forget about your absolute value symbol. Absolute value of x plus 7 equals 3. Now, think about what this means. There's a number that when you add 7 to it, and then you get the absolute value of it, you'll get 3. There are 2 values, 2 different numbers that will work for this x variable. That's what happens with absolute value, is usually there's more than one number that will make this equation true. The way that you discover what values will work is you free this x plus 7 out of the absolute value cage by making it into 2 different equations. One where it's set to +3 and one where it's set to -3. When we had our lesson, which is recorded on YouTube, we talked in depth about why. It's a complicated explanation at this point. If you don't remember it, we're just going to simply memorize that you set it up. You can get rid of the absolute value symbols by breaking it up into 2 different equations, one set to positive, one set to negative. Do you guys understand? Okay. Then we just solve for x. x minus 7, x equals negative 4, minus 7, x equals negative 10. There are two values for x. You want me to prove that they both work? This is another one where you are guaranteed to get the right answer by plugging it back in. You can verify that you got the right answer. 2 times the absolute value of x, which is negative 4, plus 7, minus 6 equals 0. Let's first check our negative 4. Negative 4 plus 7 is 3. The absolute value of 3 is 3, times 2 is 6. 6 minus 6 is 0. Does it work? Great.
Yes.
All right, let's try the negative 10. 2 times the absolute value of x, which is negative 10, plus 7, minus 6 equals 0. Let's see if that works. Negative 10 plus 7 is negative 3. So see how we ended up with a 3 and a negative 3? But now that's going to be absolute value to be positive 3, just like this one. Positive 3 times 2 is 6, minus 6 is 0. See how that works? So we guarantee the correct answer. And guys, with something like this, when you get multiple choice, just plug in the answer choices if you get stuck. Plug in all the answer choices, see which one works. And a lot of people had questions about this. This symbol, positive, negative, is basically saying positive 4 and negative 4. Stay awake. I know it's math. It's not the most exciting thing, but we have midterm coming up. Next question. Oh, let's see, 4. Next question, please. I'll also take questions that are more like, I got this answer right, but I'm afraid that I'm gonna forget to do this step. How can I remember how to do this step? Like,
We're doing that to number 2.
number 2? All right.
Oh, and number 3.
And number 3, okay. So number 2 says Kendall bought 6 notebooks. So did you need help on A and B?
Mainly just B.
Okay. B is definitely really tricky. There's a way to set up the equation. It's kind of tricky. Let's go through A first. But then there's like a shortcut to do B that's like so simple. Kendall bought 6 notebooks and 3 pens for $27. So again, we have 6 notebooks and 3 pens for $27. The cost of one notebook is $1.50 more than the cost of one pen. What is the combined cost of one notebook and one pen? So you were able to get this? Or do you want me to go over that part too?
In that part too, because there are different.
Oh, okay. So I'm just gonna, so 6 notebooks and 3 pens. I'm just gonna write that out. 6 notebooks and 3 pens equal $27, right? The cost of one notebook is $1.50 more than the cost of one pen. So the cost of a notebook equals $1.50 more than the cost of a pen. So the pen plus $1.50 is going to be the cost of a notebook. Because it says the notebook costs $1.50 more than the pen. So whatever the pen costs, let's just say the pen's $1, which I don't think it is. So if the pen's $1, to know what the notebook would be, just add $1.50 to it. So that's how we set up that equation. Now, so we're talking about the cost of a notebook and the cost of a pen. Now over here, we set this up 6 notebooks, which means 6 times the cost of a notebook plus 3 times the cost of a pen is going to total $27. whatever the cost of a notebook is, multiply it times how many notebooks, 6, and then add that with the cost of the pen times 3 pens, and you'll get $27. So we have two separate equations, we have a system of equations. So I'm gonna simplify this by realizing that the cost of the notebook and the cost of the pen, those are our variables. So we'll simply say that N represents the cost of a notebook, P represents the cost of the pen. So our first equation would be 6N plus 3P equals $27. Sometimes our variables represent the cost of the product, and sometimes the variables represent the number of items, right? It just depends on which information in the problem is a variable, which is the one that we don't know. In this case, we don't know the cost. So then I have, this is my first equation, and then my second one is the cost of a notebook, which is just N, equals the cost of a pen, P, plus 150. Now, which method would we use to solve this?
Substitute.
Substitution, very good. So we would take our first equation here, 6N, and N is this. So instead of N, we're gonna write P plus 150 plus 3P equals 27. So we have 6P plus 9 plus 3P equals 27. Combine and we get 9P plus 9 equals 27. Subtract 9 on both sides. 9P equals 18. Divide by 9, divide by 9. And how much is the cost of a pen? $2. Then we know that the notebook is whatever the pen is plus 150. So that would be 350. So the notebook is 350. The combined cost, P plus N, would be 550. Now here's where the next part, so this is our combined cost of a notebook and a pen. And then if she wants to buy an equal number of notebooks and pens with $40, what is the maximum she could buy? Well, that's basically like saying, you're like leveling the playing field. So if the total amount you can spend is for $40, then you can, and this is the combined cost, it's kind of like saying like, let's just forget that they have different prices, but let's say they're just like together, they join together to make 550. All you have to do is take what she wants to spend and divide it by 350. I don't know why I wrote it like that. You could just do 40 divided by, I'm sorry, not 350, 550. 40 divided by 550. Now when I do that on a calculator, 40 divided by 550. Yes, so you're going to get, this is how many items she can buy with $40. But it says, what's the maximum? So can she buy 7 or 8? 7. She only has enough to buy 7 because she can't buy a third of an item, right? So 7 of each. That's it, guys. We'll continue tomorrow. Please make sure you are completing whatever you did not complete today. So that was number